Of course, during the Getting Started module, we deployed vSphere High Availability on our cluster to protect from failures of a given host. We're going to take a little bit more of an in-depth look at that now. So we go to Configure and vSphere Availability. First of all, we have HA is turned on. Really simple. So let's just go into Edit and take a look at some of the other options there. So host failure response, if we have a failure of a VM, do we want to restart the VMs or just leave them? We're going to want to restart the VMs, otherwise what's the point of high availability? However, you can set that to disabled if you perhaps need to disable HA temporarily. The default VM restart priority. So when it needs to restart all of the VMs, vSphere HA makes no guarantees whatsoever. It will endeavour to restart all of the VMs, but if there is not adequate resources to do so, it won't be able to do so. So, which VMs do we start first, and which ones do we leave to the very end when we may have run out of resource? So on each virtual machine, we can set a priority, and in here, we decide what the default is. Now, it makes sense that that would be medium, because then we can elevate some to high, and we can downgrade some to low if we want a bit more control over that. One thing we can do with HA is we can configure dependencies between VMs, so that in the event of a hardware failure and the virtual machines are restarted on another host, we can make sure that our database server is available before we start our application servers. And these settings here configure how we decide when that dependency has been met. Do we simply wait for vSphere to have allocated the resources, or do we wait for the VMware tools heartbeat to have started to tell us that the virtual machine is alive and ready? Then we have host isolation response. So in the event that a host cannot talk to the network, what do we want it to do? It's still there, all of the VMs on it are still running, but no one can access them. We know it's alive because it's using the vSphere heartbeat data stores, which we'll get to in more detail in a moment, to communicate with the other hosts and make them aware it is available. But they have become aware that it is offline. So what do we want it to do? Do we want it to power off and restart the VMs? Or do we want to shut them down? Or do we want it to do nothing? So disabled, it will just keep those VMs running on that host and they will not be restarted elsewhere. So at that point, those VMs are inaccessible to the users. Power off will attempt to restart the VMs on other hosts, but it will do so by literally just powering off the VM. It will not do a clean shutdown. And shutdown and restart will send a clean shutdown request to the operating system first, and then attempt to restart them on other hosts. Data store with PDL, so that is permanent device loss. So that is where vSphere has identified that the data store is no longer in existence. It has paths to the SAN, but the SAN is saying that data store doesn't exist here. So what do we want to do about that? Because it could well be that there's a masking issue configured on the SAN, so this host can't see that data store anymore, but the other hosts can. So by default, it will power off those VMs and restart it on another host where the data store is actually mounted. APD, or paths down, we're getting absolutely no response from the SAN with this. All of the paths that we have, it will not respond. We don't know. It could well be there. We don't know. It could have been completely unplugged. We just don't know. This is different to the PDL, the permanent device loss, where we have communication with the SAN, but the SAN is telling us that that LUN doesn't exist. With this, we are getting absolutely no response on all of the paths for that data store. So what do we do? Power off and restart VMs is the default. So it will power off the VM only if it determines that it can be restarted on a different host. This is the conservative restart policy. So if there are other hosts that can access that data store, it will power off the VMs and restart them on another host. If that data store is showing all paths down on all of the hosts, it will try to keep the virtual machine running. So the virtual machine at this point is probably throwing an awful lot of errors because it can't read or write from its disk. Imagine unplugging the hard drive of your laptop whilst it's actually running. The aggressive restart policy will shut down the VMs if it determines that the VM can be safely restarted on a different host, same as the conservative one, but also if it cannot communicate with any of the other hosts, it will also shut them down. In the conservative restart policy, if it can't communicate with the other hosts, it will keep the VMs running because it doesn't know if the other hosts can restart that VM or not. In the aggressive restart policy, if we can't check in with the other hosts to see if they can start that VM, then we will shut it down anyway. VM monitoring uses the VMware Tools heartbeats. So this is the VMware Tools we installed inside of the guest to find out if the operating system on the VM is still running. So if the VM hangs or blue screens and is stuck, then this can allow us to configure vSphere to restart the VM automatically. Additionally, we have this VM and application monitoring. Now, this requires that your application supports certain APIs created by vSphere specifically for this. If you have that support and you have turned this on and the application stops responding, the virtual machine will be automatically restarted. And we can see here we have some sensitivity settings to say how often we monitor the VM and how long we want to wait for a response. Admission control. Now what this does is tries to avoid a situation where we have deployed more virtual machines than we have capacity for in the event of a failure. So by default, this is configured to allow the cluster to tolerate the loss of one host. And with admission control enabled, it will not allow us to provision more virtual machines than can be started in the event that we lose one host. Now we only have a 2-node cluster, so that means it's only going to allow us to start so many VMs that can run on one of those hosts, because if we lose one, we want to be able to restart all of the VMs on the other host. If you are getting to that point where you've created more VMs, then you will be able to restart in the event of a host failure. It will tell you you cannot. It will allow you to create the VM, but it will not allow you to power it on. If you have an existing VM that you've shut down, again, you won't be able to power it back on until you sort out the resource levels in the cluster. Heartbeat data stores, I alluded to a couple of times previously. So in the event that the host cannot communicate with the other hosts in the cluster, it needs some way to find out, are the other hosts all dead, or is this that my network connection has a problem? And the same with the other hosts. The other hosts say, host 1 has gone down. Is it down, or is it just lost network connection? It needs a way to understand that. And the way it does so is using the shared storage data stores. So the default is it will use the data stores that you specify in this list, but it will automatically add data stores if it needs to. It wants at least 2. So at the moment, none are ticked. So it's going to pick 2 data stores to use for that heartbeat. So obviously we only have 2, so it's going to use both of them. If you have more than 2 data stores, you might want to come in here and select essentially your preferred data stores for this. Maybe you have a management data store where your vCenter is or something like that.